Imagine boarding an elevator on Earth that doesn't just go up a few floors, but climbs tens of thousands of kilometers straight into space. No rockets, no violent liftoff, just a quiet, steady ascent into orbit. It sounds like science fiction, and for most of history, that's exactly what it was. But today, a growing number of scientists, engineers, and even entrepreneurs are seriously exploring the possibility of building a space elevator. Not in a distant future, but within this century. Why is this idea gaining traction now? What are the actual engineering challenges? And is it a fantasy or something that's quietly becoming imminent? Let's start with the vision. A space elevator would be a structure anchored to the Earth, extending all the way to geostationary orbit, roughly 35,786 kilometers above the equator. At that altitude, an object orbits the Earth at the same speed the planet rotates, appearing stationary in the sky. The concept involves a tether stretched from the surface all the way up to a counterweight in space, held taut by centrifugal force. Along this tether, mechanical climbers would ascend and descend, carrying cargo, equipment, and eventually even people without using rocket fuel. The appeal is obvious. Rockets are expensive, dangerous, and incredibly inefficient. Most of their energy is spent just fighting gravity and air resistance to reach orbit. A space elevator would eliminate the need for rockets to lift payloads into space. It would reduce launch costs by a factor of 100 or more. Imagine launching satellites for a few $100s per kilogram instead of tens of thousands. That alone could revolutionize space access. But here's the catch. Building something that tall, far taller than any skyscraper, mountain, or even orbiting spacecraft, is beyond anything we've ever done. The engineering challenges are staggering. The biggest problem? Materials. To work, the space elevator's tether must be both incredibly strong and extremely light. No known conventional material, steel, titanium, Kevlar, can support its own weight over such a length, let alone carry climbers and cargo. Enter carbon nanotubes and graphene, materials with theoretical tensile strengths far exceeding steel and a fraction of the weight. In theory, a ribbon of carbon nanotubes could support a space elevator. But in practice, we can't yet manufacture nanotubes in the required length or quality. That's changing. In recent years, materials science has made rapid progress. Scientists can now grow longer, purer carbon nanotubes in labs. Techniques are improving. Some researchers believe we may be able to produce elevator-grade materials within decades. It won't be easy. We're talking about a tether tens of thousands of kilometers long, thinner than a pencil, yet stronger than anything ever built. And that's just the material. We'd also need to solve power delivery for the climbers. Since there's no onboard fuel, climbers would likely rely on beamed energy, laser or microwave systems transmitting power from Earth to receivers on the climber. This concept is being tested today in small-scale lab demonstrations. But scaling it up to power tons of cargo, moving at hundreds of kilometers per hour, is a different story. Then there's orbital debris, space junk circling the planet at high speeds. A thin elevator ribbon stretched into space would be vulnerable to impact. Even a small piece of debris could shred it. Avoiding collisions would require constant monitoring, perhaps even dynamic tether adjustment using thrusters or tension control systems. Weather also presents a challenge. The lower part of the tether would need to withstand winds, lightning, and storms. One idea is to anchor the base of the elevator on a floating platform in the ocean, near the equator, away from major storms and population centers. This location would also reduce political complications, allowing for international cooperation. And what about the counterweight? To keep the tether taut, it needs a mass beyond geostationary orbit. This could be a large satellite, a space station, or even spent rocket stages bundled together. It doesn't need to be extraordinarily massive, just positioned correctly to provide the right centrifugal force. Now, let's talk economics. Even if we solve the engineering problems, who pays for it? Building a space elevator could cost hundreds of billions, possibly trillions, of dollars. But the long-term savings could be immense. Once operational, a space elevator could deliver regular, low-cost cargo to orbit. It would make massive space stations, lunar missions, asteroid mining, and even Mars colonization far more viable. And the race is already on. Japan's Obayashi Corporation has proposed building a space elevator by 2050. The International Space Elevator Consortium holds regular conferences, bringing together scientists, engineers, and policymakers. Several private companies are working on key technologies: climbers, beamed power, lightweight materials. Space agencies are watching carefully. While no one's breaking ground yet, the groundwork is being laid. There's also growing interest in lunar and Martian space elevators. Unlike Earth, the Moon and Mars have lower gravity and no atmosphere. That means the material requirements are far less extreme. We could realistically build a lunar elevator today using existing materials like Kevlar. This could provide cheap cargo transport between the Moon and lunar orbit, vital for future moon bases. A Martian elevator is slightly harder, but still far easier than one on Earth. So perhaps the first space elevator won't be on Earth at all. Maybe we'll cut our teeth building elevators on the Moon and Mars, learning, refining, scaling up. Then, in a few decades, we bring that knowledge home, and what seemed impossible becomes routine. But let's step back for a moment. Why are we even talking about this? Why not just stick with rockets? Because the future of space isn't just about launching missions. It's about infrastructure. If we're serious about becoming a multiplanetary species, if we want to build cities on the Moon, send people to Mars, and mine asteroids for resources, we need reliable, cost-effective ways to move mass off Earth. Rockets are good for short bursts, but for a permanent human presence in space, we need a highway. A space elevator would be that highway. It would also open new possibilities. Think of space tourism, manufacturing in zero gravity, massive orbital telescopes, space-based solar power stations beaming energy back to Earth. With a space elevator, all of these become economically feasible. Of course, risks remain. A damaged tether could cause catastrophic failure. The ribbon might whip around the planet, creating devastating debris. Terrorism, sabotage, or war could make the elevator a target. That's why any plan must include redundancy, safety protocols, and international agreements. A space elevator wouldn't just be a technical project, it would be a political and societal one. Still, the potential is enormous, and history shows us that impossible ideas often become real once we choose to pursue them seriously. Flight was once fantasy, so was space travel, the internet, electric cars, artificial intelligence. In each case, a combination of vision, technology, and persistence made the dream real. So where does that leave us today? On the edge of possibility. The idea of building a space elevator may still sound wild, but the pieces are slowly falling into place. Materials are advancing. Power systems are evolving. Private space is booming. And humanity's hunger to reach beyond our planet has never been stronger. The space elevator isn't here yet, but it's no longer just a fantasy. It's a vision in motion. And as long as we keep pushing, scientifically, politically, and economically, it might be closer than we think. Thanks for watching. If you're fascinated by the idea of a real-life space elevator and what it could mean for the future of humanity, give this video a like and share it with someone who dreams of space. And don't forget to subscribe to the channel, because this is just the beginning. We've got more mind-expanding stories about space, science, and the future coming soon. Until next time, stay curious and keep looking up.